Hi, I'm going to kind of walk you through how to solve problem 7 on the midterm exam. So the first thing to recognize is that the flux through a closed surface, it's Gauss's law, is going to be 0. So you want to figure out that the figure in question is actually a closed surface that you can split into 3 different sections. So there's this teal section that's rectangular that and then there's this shaded section that I've denoted in pink, as well as this flat bottom. So if you'll recall that the flux through this flat bottom section is going to be 0 because none of the magnetic field is really going through that surface. So you can rewrite what this concept here by saying that the flux through this teal section plus the flux out of this pink section is going to equal 0. So the flux through this teal section is actually pretty easy to calculate because all of the magnetic field is basically going through this surface. So that's just going to be B, the magnetic field, times the area of this section. And so that's going to end up being 1 Tesla times 3 meters times 10 meters. And an important thing to recognize is that due to sign convention, the flux into a surface, so into this teal surface, is denoted as negative. So actually the flux through the teal section is going to be negative 30 Tesla meters squared. So you can plug that back into our original equation, which says that negative 30 Tesla meters squared plus the flux through the pink region equals 0. So if you solve for the flux through the pink or shaded region, which is what we are solving for, you get that it is 30 Tesla meters squared, which is the answer.